Hello, everyone. This is our 2025 submission for the Fall Virtual Project Showcase. So we have powered with Gavii Cybersecurity locally here in College Station to build an AI-powered compliance chatbot that integrates into their existing CMMC IQ platform that is currently in development. So my team members are Abhinav and Nicholas, and I'll be presenting. My name is Joyce. So just to give a little bit of a brief background on our project, the DoD has plenty of cybersecurity regulations, and what we're focusing on is the cybersecurity maturity model certification. So there's 3 levels, depending on what kind of information or contracts you might be handling, but Gavii specializes in level 2 compliance, which is advanced. And level 2 companies deal with controlled, unclassified information and the security and protection regarding that information. So oftentimes, mid-sized and small firms have a really hard time parsing through the documentation required to enter into these contracts and deal with this kind of information because the publications are controlled or written by NIST, which is the National Institute of Standards and Technology. And there's over 200 final and draft publications regarding CMMC compliance. So our first element of our chatbot solution is a web scraper. And the purpose of the web scraper is to crawl the existing NIST government SP 800 listing page for drafts and final publications that include cybersecurity regulation information. So the purpose of web scraping is to extract the metadata from these pages. This includes the title of the publication number, and the associated keywords, etc. And this metadata is stored in MongoDB in our collections. Our second element of the chatbot solution is a PDF parser. So after we have stored these publications locally into our code base, the PDF parser automates the extraction of text chunks from the NIST documents and embeds them into a vector embedding using a free model called Zenova. And the vector index is searching based on cosine similarity, which will come in later. So all of our text chunks and PDF metadata is stored in MongoDB. The first is NIST chunks. This is where the paragraph texts are stored, and SP 800 docs, which stores our publication information, keywords, and number. So all of this is pulled together in our RAG backend. So RAG is retrieval augmented generation, and this is able to use vector search to specialize AI queries for NIST documentation. So when the user asks a question to the chatbot tokenizes each of the words in the question, and we give it a scoring based on how many keywords or publication titles we can find a match to. When we find the best match, we're able to use the vector search index to go through the chunks within that PDF and use cosine similarity to compare the embeddings and return the best matches to the chunks that have the most similar meaning or will be best used to answer the user's questions. The most similar chunks are sent as context to Perplexity, which is the large language model of our choice that we are using due to its formal language and educational context and ability to cite sources. So our main project outcomes, just to go over them again, is a compliant RAG system along with documentation that is able to take a user query, match publications, and send chunks over to our Perplexity API based on context similarity. And we also have functional chatbot UI, where responses are timely and sources are cited for the user to look back on. So now I'll provide a quick demo. We have existing chats that are already here. We can start a new chat and delete a chat. But we'll start a new chat and we can ask a simple question such as summarize NIST 800-172, which is an important document for CMMC Level 2 compliance. As you can see, the chatbot is thinking and it returns a response. So this response includes key features of NIST SP 800-172 with the purpose, scope, and key requirements, all of which have been pulled directly from the publication itself, either through paraphrasing or direct quotes, which shows that the chatbot is actually using the context that is sent over to it accurately and incorporating it within its answer. At the bottom, we can see the sources that are most similar that the user might want to visit, along with PDF links that go straight to the NIST government website. As you can see, the top matches for the user to look at is the SP 800-172 document itself. And the PDF chunks used is just to show what the best matching chunks were that were sent over to Perplexity. And as you can see, all of those chunks were sent from the SP 800-172 PDF, which makes sense given that our question was about NIST 800-172. So our second question is something that's a little more specific for CMMC level 2. How should an organization protect controlled unclassified information, otherwise known as CUI, when stored and transmitted? This is more of a question geared towards SP 800-171 and 172. So when we get our answer, we can see that Perplexity gives us some key requirements to include. This includes encryption of CUI, control and restriction of access, media protection, and network protection. These are directly, elements of the document itself. So once again, Perplexity is using the context that is given to it. And they do provide more detail based on NIST SP 800-171 revision 3, which is stored within our code base. If we look at the metadata sources that we're pulling as the best match, we can see that 171 revision 3 and 172 revision 3 are part of our top matching sources. And the chunks that are being used and sent over to Perplexity are SP 800-171, which is the best match for this question. So hopefully you learned a little bit about our AI-powered chatbot and how it's able to provide answers grounded in the context that we give it based on our NIST publication data that we've web scraped from the government website. So thank you so much for watching and have a great rest of your day.